And he's kind of like the Energizer Bunny. He keeps flying and flying.
He's Mission Specialist number 2. He was selected as an astronaut by the European Space Agency. He's from Viterbo, Italy. And he has flown to the International Space Station twice.
All right, so that's the crew. They will be prepared, suiting up. By the way, Peggy Whitson,
Chief astronaut.
Chief astronaut there. She's the one who has the current American record for time in space. And right behind her is the person who will end up beating that. Ron Constantino now joins us from Boeing. He's been here watching the crew get in with us, or getting suited up. Ron works on the express logistics carrier part of the space station. And the last time we talked to you, we were hoping to launch that part that day. Think we'll go today?
For about the next 20 minutes or so.
Very nice.
Cross and everything, we're ready to go.
All right, you were ready to go last time. You're ready to go this time. Tell me a little bit about the express logistics carrier. Where is that going on the space station?
So the express logistics carrier is going on, I believe, port 3, being connected to the space station. It's the last express logistics carrier to go up to the space station. It's bringing up multiple ORUs. You have the SPDM arm, which is very important for the SPDM.
Well, for all these acronyms, we have a lot of people just joining us. So explain what these are.
Space Dexterous Manipulator arm for the CSAs, for the Canadian arm, and the hand they brought up basically for the
backup arm that's going to go up on the space station.
Correct.
Right.
It's the very important, gives them a backup capability in case anything ever happened in future orbit or ISS operations.
And this is something you need because, as we were saying, without the space shuttle, you're not able to resupply. So, really important right now to fly backup hardware.
Correct, especially large items like this. There will be, at this current moment, no other methods of bringing that hardware item up in orbit.
And Leroy, you've had to use backup equipment on your space station mission.
Absolutely. And you're just listening to you talk here. I was taking back to our EVAs and going up on station and thinking about where we're going to put spares and all that stuff, work I did in the EVA branch back when. And I remember the express logistics carrier when it was being developed. In fact, I think you probably worked with John Zelon over in Boeing on some of these things.
Yes, we worked a lot of upfront design, and make sure our safety analysis and mechanical designs were functioning with the space station. We didn't want to bring these EOCs and cause any harm or any concerns to the space station itself. So he did a lot of the upfront work.
Remember,
Express Logistics Carrier. Sorry, our KSC folks, we tend to use acronyms.
So many acronyms around here.
Correct. There's so much hardware, so much technical data. We tend to throw acronyms around. We tend to forget. A lot of people who don't work at Kennedy Space Center don't understand those acronyms.
Well, it's always great when you see we've had previous NASA administrators said, and there's an acronym for that, but I don't remember. It's like,
actually, what's really bad is when you know the acronym. You know you've been at NASA too long when you know the acronyms, but you don't remember what they stand for. You know what they mean, but you don't remember what they stand for. And they've embedded acronyms inside of acronyms.
Ooh, yeah, that could be rough.
That is correct.
So, okay, now you're going to put this up. You're going to install the backup arm as part of this. What else is there?
So you have a common transport carrier, which has multiple arm control unit. One arm control unit. You have remote power control modules. I believe 10 of them inside this CTC controlled transport container, which is very important for the space station. It gives multiple backups for the space station.
And those are basically relays, right?
Relays, yes, power relays. Then you have SAS antennas. We're bringing up 2 of those, which is very important for communication, sending data back and forth from Houston, Marshall, wherever we want to send data from on orbit. You're also carrying an extra ATA tank that's for the ammonia that we're flying up there to help cool the station, as well as a high pressure gas tank filled with oxygen.
And the ammonia is used, obviously, as we were saying, to cool off the space station. On this mission, and as part of a spacewalk, some astronauts will replenish one area of the space station with ammonia to help with the cooling system. So it's something that is constantly needed. And so just many more tanks on the outside ready to go for keeping it cool.
Now we are bringing up one science payload. It's the Science Test Program H3 from Houston. It's agreement between NASA and the DoD guys, where a bunch of they agreed to give some space up in orbit for the scientists to bring their experiments up to do on-orbit experiment. The STP has actually 4 experiments on there. You have the Vader, which tests emissivity and heat transfer with different materials. You have a disk. It's a high digital camera system for possibly future satellites or payloads for orbit. You have also the Canary, and I believe the MTEX, which are other experiments to test what the, say, atmosphere in space does with different materials as well.
And this experiment package will be on the logistics carrier, the Express
Correct,
carrier?
Yeah. It's our only powered scientific payload on the Express Logistics
Now,
carrier.
will that be retrieved later by EVA?
No, all the data is transmitted through Houston and Marshall, so they're going to get real-time data. It is going to fly back eventually actually not fly back, burn up on a SpaceX trunk.
Well, technically, it's flying back.
Yes.
And
part
flying
way
back,
anyway.
and, yeah, then burning up.
It's not at a recoverable stand.
Right, exactly. This is something, obviously, that the key part of it is exposure to space.
Correct.
This experiment will be exposed to space, much like, LDEF missions, an LDEF mission in the early shuttle. Oh, look, I've thrown out an acronym myself. After I scold you, I decided to make up a long duration exposure facility.
Yep.
So, that they have a lot of experiments that stay outside and stay out there for a long time to see what happens over time. So, quite a few things on this carrier.
Yeah, we fly a full complement. We do leave one empty site for a future payload. It's called the SCAN payload, which will fly up on one of the SpaceX missions. I believe it's SpaceX 2. So this ELC is one of the most populated decks that we have flown up so far.
And do you remember the weight of this full carrier?
It was about 14,000 pounds.
14,000 pounds for that. That's about, I believe, 15,000 for the AMS, if I'm not mistaken. So, adding up there.
Yes.
Now, of course,
David, in the design that goes into these logistics carriers, it's easy to think of these carriers as just simple platforms, but there's actually so much that goes into them. The mechanisms, they have to be EVA releasable, of course, have the space for astronauts out there to have their handholds and be able to get these boxes off, these ORUs. And, a lot of these mechanisms, I remember thermal vacuum testing, a lot of them, you think they're real simple and they're going to work, but there's something wrong under thermal vacuum conditions. So there's a lot of engineering, shouldn't be discounted, on how much engineering goes into these logistics carriers.
There was multiple space agencies involved with the build-up of the Express Logistics carrier. The carrier itself, the Bear carrier, was built up by Goddard. And then these multiple ORUs, you're talking about CSA, Canada Space Agency, built some hardware. Guys from Arizona for the STPH-3 were building their experiments, from Houston, from all over the country. We're building all the piece parts to put it together on the ELC. So here at KSC, it was interesting integrating all of these multiple teams together to build up the final piece part ELC for this mission.
And then together working through all the hiccups and everything you've come up with in testing that you have to...
Correct, yeah. We experienced multiple variables, but I would have to say the people I've worked with through the years on the ELCs were the most intelligent, if not the most diligent, working through these variables. We find an issue and work right through it.
And Leroy, that's an interesting point. You're talking about even the handholds are important. You have to design the carrier with enough handholds for an astronaut to be able to navigate their way around, to move parts, but also to get there, because if you don't have those
if you don't have that translation envelope, you're not going to be able to get to where you're going in order to get your body in a position to use your power tools to release the latches and get that ORU off and get it to where it needs to go.
And kind of a tough place to find out if you're in space. You don't want to find out right out there that, hey, this latch doesn't work. And there have been some missions where
there's been small glitches like that.
Knobs are hard to turn or latches are hard to turn, and that's obviously why there's so much engineering that goes into making these.
And so much testing.
Testing.
But even with all that, every now and then there's something that kind of unexpected happens.
That's true. By the way, the live picture, just so you're seeing this, is the final inspection team out of the launch pad taking a look and making sure everything is okay. So they're going to check out everything.
No errant pip pins, hopefully.
Oh, yes.
Nothing on the app disconnect.
Yes. Leroy's mission was delayed by an errant piece of metal in the launch pad in a place it shouldn't have been.
Sure, glad they found it though.
Yeah, you don't want that kind of thing shaking free there.
No.
So Ron, your thoughts now. We're on the 30th year of the Space Shuttle program. We're past the 30th anniversary of that. We're past the 50th anniversary of first person in space, and we're about to see this thing that has been flying, for 30 some years with the help of all the contractors, Boeing and everyone else. What are your thoughts on that?
As a Boeing employee, it's just amazing that this, especially Endeavour, being the 25th flight, has flown so many times, and the focus that the workforce here and all around the country has on making sure that this thing launches not appropriately but also safely. As a Boeing employee and an aerospace worker, I couldn't say I'm more proud of the people I work with. And I'm looking forward to the future, to transition, not to just the buildup of the space station, but the part of actually using it for what its intended purpose is. Experimentation, utilization, and expanding our innovation down here on Earth.
And I see you've got your Endeavour ribbon there.
Oh, yes.
That's great.
I wish we should have thought of that. Do you have your Endeavour ribbon?
I do not. That's the first one I've seen. That's fantastic.
Yeah, these were handed out, and I think they started this past 2 missions, and
okay.
Everybody I work with at KSC, we wear them because it's just memorable moments for us. Some we'll keep for our lifetime.
Where are you going to be watching from today?
More likely I'll probably be at the LCC watching it from.
All right, Ron Constantino from Boeing. Thank you so much,
gentlemen.
Appreciate
Enjoy the day.
Thank you.
Thank you.
All right. Meanwhile, let's go back and look at launch pad there. Space Shuttle Endeavour poised for liftoff, and in the next 15 minutes or so, we should see the crew of Space Shuttle Endeavour walk out of that building and head into the astronaut van, where they'll take a 20-minute ride to the launch pad. So getting ready for that moment, and we'll see a huge crowd as we did last time. Despite the early hour, we have lots of viewers outside. We've seen people packing the roads. On the way in, Leroy, I saw people parked along this, talking 2 in the morning, 1 in the morning. Hundreds of people parked all over the place.
Yeah, I mean, it was actually not too bad coming in around 2:30 in the morning, but then coming here to park, even this early, the press site was pretty full, and they, for the first time, brought me way out to the grass, and it took me a while to get up here.
Same here. Yeah, I was kind of impressed. I'm glad in a way, because this space program deserves to get covered by media, deserves to be seen by the American public that's paying for it.
Absolutely.
And seeing a little bit of the return, seeing what they're getting for their money. So
right.
You're a guy who can help explain that. What's a little brief explanation of what the public gets for the money? Because people say, they launch they waste a lot of money in space, and as Miles always says, no money is ever launched into space.
Well, you're right, David, and we could talk about the spin-offs, we could talk about the exploration, we could talk about the science experiments that we do up in space, but to me, the biggest part of a human spaceflight program, especially one which we've been the leader of for the last, almost 50 years, is the national prestige it brings to our country, and also to the inspiration that it provides to young people. I myself was inspired by the space program to study math and science, and to become an engineer, and eventually to become an astronaut. So I'm a big believer in it, obviously.
You became an engineer. So did our next guest, Rachel Wiedemann from Boeing, and she's joining us here. The tile engineer, tell me a little bit about, as we look at that live picture, beautiful shot. You know a lot about this stuff, a lot about this thermal protection.
I do. Everything you see on the outside of the vehicle I've worked with. It's extremely exciting job. It's a very hands-on job. I usually spend about half of my days in the high bay talking with the technicians, working very hands-on. It's very fun, and there's so much work. I mean, you're talking over 20,000 tiles, over 9,000 blankets. There's a lot to do to refurbish these things in between flights.
And you've got the brie tiles, the very dark ones, which you've had a personal stake in, because the name of it, the Boeing reinforced tile.
Boeing reusable insulation.
Okay.
Yes.
Hey, I got.
Yeah, you and acronyms. Dave, we're going to have to give David out the acronyms.
Burning up on that one today. So, that one is the one that now goes around the doors and areas that need to be reinforced.
Correct. Those are a tougher, more resilient tile. So we put those around all of our lower surface penetration areas so that we get that extra amount of protection. We're not going to have any flow paths into the vehicle. Those are not going to break.
Now, you see this vehicle out there. You see all these different types of thermal protection. Did you ever think you'd be working on this, first of all, when you first saw the shuttle's launch?
It's been a dream for a while. A story my mother likes to tell is I always said I wanted to work on the space shuttle, and now here I am. So it's pretty incredible for me.
Now, how long have you been working here?
I've been working out here for 7 years.
And you said you work in the high bay, so you're
the orbiter processing facilities.
In the OPFs.
Yes.
So you were integral and part of this one here. How long have you? I guess you've been associated with Endeavour for 7 years as well.
Yeah, all the vehicles. I primarily worked with Discovery, but I'm a thermal analyst on all the tiles on all the vehicles. So whenever there's an image that requires any type of thermal analysis, I get involved. So I've definitely been involved with Endeavour as well.
Now, do you work with there's another acronym, the BLT?
Yes, actually, that's an extremely exciting experiment. This is going to be the 5th time that we're flying it. and it's data that we've gotten it 4 times now. But
by the way, just
previously,
the BLT, that's basically a bump in a tile that's manufactured
Correct.
in there to disrupt the flow purposely with some thermocouples down the road.
Correct.
To see how the different tiles heat up behind it when the flow is disrupted.
Yes, exactly. BLT stands for boundary layer transition, and what we're doing is normally we deal with steps between tiles that are on the order of 50 to 60 thousandths of an inch at the most, and now we're actually fabricating a bump on the lower surface of the vehicle that is half an inch. So we're talking something that's 10 times larger than what we would normally see on the lower surface of the vehicle.
Now this is something we've seen before with when a gap filler comes out. When there was a gap filler that came out,
right? And there was the concern that they were going to disrupt
the concern was it would disrupt it enough that it could have burn through. So they sent out Steve Robinson to pluck that gap filler out. But this is going to help answer how much the shuttle can take.
Exactly.
Without I should point out without excessive danger, because they don't obviously want to create a level where they know it would be dangerous. So you've done this experiment in stages?
We've done this experiment in stages. We started with a 1/4 inch protrusion, worked our way up to 0.35, and now we're at a 1/2 inch. So we've definitely worked our way up to much higher levels, and we've been able to validate that with the data that we've gotten from our thermocouple sensors and from the analysis that we've done.
So you've got a pretty good model now, and this would be one more data point to further validate
Exactly,
that model.
and this is data that we've never been able to get before, so this is going to be really great for future vehicles that are going to be developed.
Because obviously she's talking about if you disrupt that the flow as you're re-entering anywhere, right behind where that disruption is, it gets excessively hot, so you could have a danger of burning through in that area. And now they'll know exactly how much can be taken. Where now it's I don't want to say a guess, but it'll be less of a guess. There'll be more calculation, more science behind that.
We'll be more precise. We work with conservative estimates now. Everything is obviously within safety factors that we are very comfortable with, but we'll be able to become more precise.
Now, how many different missions have these gone up on so far?
This will be the 5th.
The 5th mission
the second one of a 1/2 inch protrusion.
Yeah, and are the angles different where the disruption happens? I remember the first one was, one certain angle.
No, they're all slightly angled. We call it a shark fin protrusion. The front edge is kind of curved. We don't want to create anything that's going to be too sharp of a transition. And they've all flown extremely well. But they're all pretty much the exact same tile with just a higher protrusion.
And where on the vehicle are these protrusions?
These are on the left wing.
Left wing, okay.
We put them behind the doors. Obviously, we don't want to cause any disruptions forward of where we're going to have, the doors where we can potentially have flow coming up into the vehicle. It's back on the wing. It's in an area where we typically see hot air already, but we're dealing with hotter, more turbulent air earlier in the flight at this point, and so we're able to quantify that.
So it's a 1/2 inch protrusion, and how long is it?
I don't know exactly how long, but about 3 inches, give or take.
Great.
I had a chance to see it there, and there's not too big a thing, but just when you look at it on the bottom, you don't realize how much data is going to come back from that. But you've seen the results of these experiments, right?
Correct.
What have you learned so far?
That the vehicle can actually take a lot more than we previously thought. Like I said, we were working with very conservative estimates previously. We're actually, it was never even imagined that we would be able to work our way up to a 1/2 inch protrusion when we first started with that 1/4 inch protrusion. So we've learned that we had a lot of conservative estimates in there, and that we actually have a very strong and resilient vehicle, and this will definitely be helpful, and I imagine trying to lower weights on future vehicles specifically.
And what have you seen in tiles behind it? Did any of them burn or get more damage, or what kind of excess temperatures did you see? Like we're talking 20 degrees, 100?
All the tiles behind it were in completely wonderful condition. We did not see any additional heating that was a detriment to the tiles we already had installed. What we did see on the actual protrusion was some glazing of our glass coating that we put on the tiles for protective reasons. But aside from that, everything was beautiful. We did not see any adverse effects from the heating.
So you just saw maybe a different temperature distribution, but nothing out of family.
Correct.
Okay.
So interesting. I mean, something's still being learned from the vehicle. 2 missions before the last, the second to last mission. You're still learning from this.
Yeah, and it's important that we do that while we have a vehicle that we can do it with.
Sure.
Yeah, while the U.S. still has a vehicle. I should ask you, you live in this area, what do you think of seeing these retire?
Well, of course it's sad for me. I work out here, I work on the vehicles, I'm very close with them. And
that's kind of like, people say they're kind of like family. They're kind,
Yeah.
you spend so much time with them,
well, and it's not just that, it's all the people out here too. I mean, we all have such a wonderful rapport. The people out here are so friendly, so wonderful to work with. And so the fact that we won't be able to work together anymore, we won't be able to work on this incredible vehicle, and at least not in the next couple of years, contribute so directly to human spaceflight. Of course, it's a little sad. We love what we do. Everyone around here has a very strong source of pride in what we do out here.
Sure. Yeah.
Now, what do you think? Where are you going to be for this launch today?
This is the first time I'm going to actually be able to watch it from out here at the press site. With the,
I haven't watched it from out here.
This is the second launch I have supported at the press site, but the first one I had to leave early, so I'm excited to have that iconic view with the countdown clock and the flag. I've never had that before.
Where are you normally for these?
When Discovery launches, I'm in the firing room, actually supporting from an engineering console. And for the other missions, I go where I can get the best view, usually up here next to the Launch Control Center.
Great.
Coming out of the hold now in 4,
All right, we're coming out of the hold.
2,
1. T-minus 3 hours and counting.
That big iconic countdown clock starting up. Right on schedule.
And the crew getting ready to walk out. They will be walking out of the operations and checkout building.
Beautiful view of Endeavour on the pad.
All right, sorry that there. By the way, Rachel Wiedemann from Boeing. The last question for you here is, what happens to you after this? Where are you gonna still be a part of Boeing, or have you thought about that?
I'd love to continue working for Boeing, and they're working really hard to try to transition us into new jobs. They're doing a really great job of making an effort to work us into new areas of Boeing. I personally, I'm a space girl. I love working with space, so I personally am not interested necessarily in going over to the commercial aircraft side of things.
Right.
But Boeing, as well as a number of other companies, are all working on developing the new vehicles that are going to follow up to the shuttle. So hopefully I'll be able to find another job working in the manned spaceflight industry. It's really where my passion is.
Well, good luck. Thank you very much,
Rachel.
Appreciate it.
Thank you,
Thank
Rachel.
you so much.
Thanks.
Enjoy launch today, and let's go live back to the launch pad and Space Shuttle Endeavour.